Hi. Okay, so here's your next lesson, solving inequalities. So we just got done learning about kind of the basics of inequalities. So talked about just how to read the signs appropriately. I taught you my little less than trick. It looks like a slanted L. That's how I remember it's less than, okay? So we also learned how to graph on a number line, and we're going to be doing more of that today just so that it becomes routine. But the main focus of today is actually solving an inequality. And solving inequalities are very similar to solving equations. There's just one little thing you have to watch out for. Now, typically, if we were in person right now, I would have us kind of explore inequalities more. So instead, I'm just going to show you my last year's notebook and kind of summarize what we did in class that day to explore inequalities. So this is not something you need to write in your notebook, but I do want you to listen to it, okay? So here was just like a basic inequality, 2 compared to 8. And of course, since 2 is less than 8, we put a less than sign there, all right? Now, what we were exploring is what happens if I add certain things to both sides? What happens if I divide by certain things on both sides? Is this symbol going to stay the same direction? Okay, is the comparison going to be true still? So just like in equations, whatever you do to one side, you have to do to the other. And that's also true for inequalities. You can manipulate inequalities however you want, meaning you can do whatever you want on each side. You can add 100. You can divide by -3, as long as you do it to both sides, okay? So we first looked at addition and subtraction. We started by what happens if I add 4 to both sides. So as you can see, I took my 2 versus 8, and I just added 4 to both sides. Now, that's mental math, hopefully, but we can write down the result. 2 plus 4 is 6, so this side would be 6. 8 plus 4 is 12. So 6 versus 12, 6 is less than 12. So the inequality didn't change. When we added 4 to both sides, the symbol stayed the same. Then we tried with subtraction, and we subtracted 4 on both sides. 2 minus 4 is -2. 8 minus 4 is 4. -2 is less than 4. Okay, so the symbol stayed the same. Then we added 100 to both sides. Symbol stayed the same. We subtracted 100 from both sides. The symbol still stayed the same. -98 is less than -92. Remember, it's deeper into the negative, so it's less than -92. And then we wanted to see, okay, well, what happens if I add a negative or subtract a negative? Maybe that'll switch the sign around. Let's see. So we added -20. 2 plus -20 is -18. 8 plus -20 is -12. -18 is still less than -12. So adding a negative didn't switch the sign at all, kept it the same. The comparison is the same. When we subtracted a negative, remember, subtracting a negative actually turns into addition. You're adding a positive. So really it's like 2 plus 20, which is 22. And then 8 minus -20 is positive 28. 22 is less than 28. So you can add a positive to both sides, sign won't change at all. You can add a negative to both sides, sign won't change at all. Same with subtraction. Whether you subtract a positive or negative on both sides, it's going to stay the same symbol in between. The inequality doesn't change. So now let's move on to multiplication and division. Okay, and once again, you don't need to write this. You're just kind of watching and observing and understanding. So here we just started with 2. So we times by 2 on both sides. 2 times 2 is 4. So we got 4 on this side. 8 times 2 is 16. 4 is less than 16. Symbol didn't change. We divided by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. 1 is less than 4. Symbol didn't change. So now we started, I think a student said, what if it's a fraction? So we times by half. 2 times half is 1. 8 times half is 4. 1 is less than 4. It didn't change the symbol. Division didn't change either. 2 divided by half is 4. 8 divided by half is 16. 4 is less than 16. So then I said, well, let's try a negative. So we multiplied and divide by a negative. Now, I mean, you can see the symbol flips, but let's go through and see why. 2 times negative 2, so we times by negative 2 on both sides. 2 times negative 2 is negative 4. 8 times negative 2 is negative 16. Negative 4 is actually greater than negative 16. That's because negative 4 is closer to the positives, right? So it's greater than negative 16. So that flipped the symbol around. Dividing by a negative, we divided by negative 2. Negative 1 versus negative 4. Negative 1 is greater than negative 4. So dividing by a negative switched the symbol around. So we wanted to test it again. We tried another negative. So this time we did a negative fraction. So we times by negative 1/4. 2 times negative 1/4 is negative half, or negative 0.5, however you want to write it. 8 times negative 1/4 is negative 2. Negative half is greater than negative 2. Reason why is this is closer to being positive, right? So it's greater. So that switched the sign around. Dividing by half, we got negative 4 versus negative 16. Negative 4 is greater than negative 16. So that switched the symbol around. So here's the moral of the story, my friends. If you multiply by a negative, you got to switch the sign. If you divide by a negative, you got to switch the sign. It doesn't matter when you add or subtract negatives. You don't have to switch the sign around. So that is the rule that we have to remember when solving inequalities. If you multiply or divide by a negative, you have to switch the sign. Okay, that's the biggest rule to remember. So let's go ahead. We're going to write some steps in our journal. So I do want you to write these down. So these are your steps when solving any sort of inequalities. So I'm not really going to do, 1-step inequalities today and 2-step tomorrow. It's the same process as equations, so we should have that procedure down already. So this is for any inequality that you have. Step 1, which is true for equations as well, is you want to simplify each side of the inequality. So we're going to say simplify each side of the inequality. Okay. Now, when I say each side for equations, you know that there's a left side and a right side. The equal sign separates them, right? Same is true for your little alligator, your little inequality. It separates the left from the right, okay? So you would look at the left side of the inequality. I don't know if Zoom mirrors me or not, but you look at the left side of the inequality, you simplify it down. What do I mean by simplify? Well, if there's distributive property, do it. After you do distributive property, or maybe there's no distributive property, then you would check to see if you can combine like terms. Okay, so you would do that on the left side, and then you would go to the right side, see if you can simplify there. After everything's simplified and cleaned up, that's where you get into step 2, okay, which would be the same process for equations. After you simplify, what do? You start moving your variables, right? So you get all your variables to one side, get everything else to the other side. So that's going to be step 2, is move variables. And I'm using move very loosely. Obviously, you have to use inverse operations to move them, okay? Move variables to one side. Constants. And if you don't like that word, Constants just means normal numbers. You can say anything else. Constants to the other side. Move variables to one side, constants to the other side. Okay. So obviously you do that using inverse operations, and we can even write that here using inverse operations. So if you're moving a positive 5x, well, since it's positive, you would have to subtract 5x in order to move it. That's what inverse means. Okay. All right, and then there's one final step. So now that you have all your variables to one side, everything else to the other, this is where you actually isolate the variable. Okay, so you get x by itself. Maybe you divide by the coefficient to do that, whatever you need to do. Okay, so this is the same steps for equations, but in an inequality world, we follow the same steps, but there's just a huge important rule that we have to keep in mind, okay? Which is, if you multiply or divide by a negative, you have to switch the sign. So you're going to write that nice and big right here. If you multiply or divide by a negative, switch the sign. And if switch the sign, if you don't know what I mean by that, you might want to say flip the symbol, or whatever you're going to remember. But instead of a less than, you would have to switch it to a greater than. Instead of a greater than, you would have to switch it to a less than. So if you want to say flip the alligator symbol, whatever makes sense to you. Okay, but you need to make this stand out in your notebook. That's the biggest rule of inequalities. If you multiply or divide by a negative, you got to switch that sign around. So I'm just going to really make sure you know it's only when you multiply or divide. If you subtract a negative or add a negative, that's not going to change the symbol at all. Okay. All right. So now let's kind of go through this process of solving an inequality. So here is your first practice question. 5 times parentheses w plus 2 is less than or equal to negative 35. Okay. So here's what I think you should do. Here's my suggestion. You know how I taught you guys to separate on the equations that we were doing, I taught you to like separate the sides. I still think that's smart. So your inequality separates your left and right sides. So if you just want to do a little dotted line, okay, basically instead of bringing down an equal sign, you're just bringing down this symbol each time. That's really it. So look at your left side. Is there any simplifying to do? Yes, distributive property. Let's do it. 5 times w is 5w. 5 times 2 is positive 10. So we have 5w plus 10 on the left side. I'm going to drop down my symbol, less than or equal to. And then on the right side, there's not even a variable over there. It's just a single constant. So you just drop it down. There's no simplifying to do. Okay. All right. So we simplified each side. Now we're going to make sure that variables are on one side and everything else is to the other. Well, locate your variables. Your variables are already on the left. There's no variables on the right. So cool. We didn't have to do anything extra there. But now you're going to want to make sure that you move all of your constants to the other side, which would be the left side in this case. Since it's a positive 10, you would subtract 10. Whatever you do on one side, you have to do to the other. 10 minus 10, what happens there? Cancels. I'm left with positive 5w is less than or equal to something. You use a calculator real quick. Negative 35 minus 10 is negative 45. Now, you subtracted 10, which you can think of as adding a negative, but if you add a negative, does the sign switch? No, okay? So really, it's this last step you have to be careful on, because more than likely you are going to divide by something on the last step to get w by itself or x by itself. So look right here. What are we going to divide by to get w by itself? Do we divide by a positive or negative? We divide by a positive 5. If you divide by a positive, do you have to switch the sign? No. It's only if you divide by a negative. I have kids that see this negative over here, or they even see that the result's going to be negative 9, and they go, oh, I got to switch the sign around. No, no, no. It's only if this number right here, I'm going to even point it out. Right here, we divided by positive. Since we divided by positive, we don't touch the sign at all. We just drop it down. So my final answer would be w is less than or equal to negative 9. Okay. Same process as solving equations, right? Same. The only thing you watch for is if you have to multiply or divide by a negative at the end. So let's talk about how to check our answer. We're not going to do checks on every problem, but you do need to know how to check it. So let's talk about how to check. Now, process is still the same. You are going to be plugging in something for w and see if the left side and the right side are making some sense here. But we don't really want to plug in the negative 9 for w. I think it's actually smarter to plug in something less than negative 9. Now, technically, since it says or equal to, we could plug in negative 9, okay? But I think it's smarter to test this less than, because if it was flipped greater than, then we would know we're off. So something less than negative 9. So you just need to figure out a number less than negative 9. Negative 10, right? Negative 10. So let's try negative 10, since negative 10 is less than 9. So we are going to rewrite this, except for instead of the w, we're going to plug in a negative 10. So you would have 5 parentheses, and then instead of w, it would be negative 10 plus 2 parentheses less than or equal to negative 35. Okay, so we're seeing if this is a true statement, if this left side is actually less than or equal to the right side. Usually when we check equations, we're making sure that you get the same number at the end. But in this case, you're just making sure that it makes a true statement at the end. Okay. So on the left side, you could distribute, you can, but you can also actually solve what's in the parentheses. Negative 10 plus 2 is negative 8. And 5 times negative 8 is negative 40. Okay, so if we drop this down every step of the way, which technically we should, we would have this statement at the bottom. Negative 40 is less than or equal to negative 35. Now that is true. Negative 40 is less than negative 35. So since that's true, we know our symbol over here is correct. That's how you check this symbol, basically. Okay, if we had made a mistake and switch around that symbol, it would come out as negative 40 is greater than negative 35, and you would know that you had a mistake, because that wouldn't be true. Okay, but it is true. So let's try another one. Here's number 2. 8 minus parentheses. Inside your parentheses is x minus 3. Is less than or equal to 3x minus 5. Okay, so separate your sides if you want to or need to. Go ahead and do that. I look at my left side. Is there any simplifying I can do? Yes, there's some distributive property. Be careful though, it's a -1 that you're distributing. So we would get -1x plus 3, drop down the 8, right? Negative times negative, positive. And then I'm going to look at the right side, 3x minus 5. Can I simplify that? No, they're not like terms, so just drop it down. And then I check one more time, is the left side completely simplified? No. I'm going to quickly add up these like terms. 8 plus 3 is 11. So I have 11 minus x is less than or equal to 3x minus 5. Both sides of my inequality are simplified. Now I can start canceling out terms or moving terms. You know me, I always like to put my variables on the left. And for my students who know that sometimes it's better to put them on the right, I would argue that for inequalities, you always want to put them on the left, because if you end up with your variables on the right, you're just going to have to switch it at the bottom. And because it's not an equal sign anymore and it's one of these dudes, kids screw up on flipping the symbol all the time. Okay, so I would say trust me and put your variables to the left. Okay. So here we go. I'm going to move this 3x over. Since it's a positive 3x, I'm going to subtract 3x from both sides. Negative x minus 3x. Well, this is like a -1. So -1 minus 3 is -4x. Drop down everything else. Okay. Then I'm going to move the constant to the right-hand side. Since it's a positive 11, I'm going to need to subtract 11 from both sides. 11's cancel. I'm left with -4x is less than or equal to -16. And then I go down here. I want to get x by itself. I'm isolating my variable. So I'm going to divide by whatever the coefficient is. This coefficient is -4, so I'm dividing by -4. Now, since you're dividing by a negative, there should be an alarm going off in your head. Wee, wee, wee. You just divided by a negative. When you divide by a negative, you have to switch the sign around. So I simply go like this to tell myself, as soon as I see that I'm dividing by a negative, I circle my sign. You don't have to, but it's just something I found helpful. And I remember, sorry, this is off the page a little bit, but I remember that I'm gonna have to flip around that symbol. So I'm left with x is greater than or equal to +4. Okay. Okay, so let's look at a check. Could you plug in a 4? Yeah, but it's better to actually plug in something greater than 4 because we want to check the direction of the symbol, okay? Especially since I ended up switching it, let's make sure that I did a decent job of doing that. So x is greater than 4. Give me a number greater than 4. 5? Cool. Let's try 5. You could try 10, you could try 8, try something bigger than 4, okay? But if we were to try 5, let's go ahead, we're gonna rewrite this, but plug in a 5 for the x's. So we would have 8 minus parentheses, 5 minus 3 parentheses, less than or equal to 3 times 5 minus 5. You are going to simply simplify this left side, simplify this right side, and you're going to see if you come out with a true or false statement. So on the left, I'm going to do parentheses real quick. 5 minus 3 is 2. So I would have 8 minus 2. 8 minus 2 is 6. So this left side simplifies to 6. On the right-hand side, 3 times 5 is 15. 15 minus 5 is 10. So we get this statement at the end. 6 is less than or equal to 10. Is that true or false? 6 is less than or equal to 10. That's true. That's how you know that this was the correct answer. It had the correct direction. Okay. Okay, so we're going to do a few more practice, and then you're going to practice on your own. All righty. What are we at? 3 and 4. Okay. Obviously, you can check these on your own, just to practice a check, but we'll practice it in Zoom also. Okay, so we're just going to solve. Here we go. We're going to do some fractions, your favorite. 1/4 x minus 3 is greater than or equal to 3/4 x minus half. Woo! Still got to know how to cancel out fractions. So if I want to cancel these out, I'm looking at the denominators, 4, 4, and 2. What's a good number that 4 and 2 both go into? 8 would work, but a smaller one that works is 4. 4 goes into 4, 2 goes into 4. So I'm basically going to times everything by 4. Okay? 4 times 1 is 4. 4 divided by 4 is 1, so that results in 1x. 4 also has to get multiplied by the -3, although a few of you still think that because it's a whole number, you don't. You do. You have to. 4 times -3 is -12. 4 times 3 is 12. 12 divided by 4 is 3, so that's 3x. Drop down your minus sign. 4 times 1 is 4. 4 divided by 2 is 2. So looky there, we just canceled out all your fractions. Now you check. Are both sides simplified? Yes. Yes. Now we can go to the second step, which is moving stuff. Move all your variables to the left, everything else to the right. You can move your variables to the right. You're just going to have to be careful when you flip it at the end, okay? So I'm going to move this 3x. I'm going to subtract 3x since it's positive. 3x minus 3x cancels. 1x minus 3x is negative 2x. Drop down everything else. Now I'm looking at the 12, trying to move it over. Since it's a negative 12, I add 12. Again, negative 2x is greater than positive 10. Took me a while. Negative 2 plus 12 is 10. One last thing to do here. We are going to divide by the coefficient to get x by itself. But oh my goodness gracious, you just divided by a negative. That alarm should be going off in your head, telling you to switch around the symbol. So we have x is less than, and then positive divided by negative is negative. So x is less than -5. Okay, now we're not going to check this, but you are going to do your graphing. You're going to practice your graphing right here. So this was from the last lesson. Let's put -5 in the middle, couple values to the left and right. If you want to count by ones, do it. I'm going to count by 5s. And this is where you have to remember, is this going to be open or closed? Open or closed circle. So you look at the symbol here. Since it's strictly less and not equal, that's going to be an open circle at -5. Okay. X is less. The numbers that are less are always to the left. So we would have an open circle at -5 pointing to the left. That's how you would graph it. Okay. Okay, now number 4, I think is a good one for you to try out right now. Pause the video and hit play when you want to check it. So we have 4 parentheses. X minus 3 is inside of that, but outside of that, you're going to subtract 7. And that is less than 2 times a set of parentheses, x minus 3. okay? I would hit pause, try it out, hit play when you're ready. Okay, simplify, simplify, simplify. On the left, I'm going to distribute. You get 4x minus 12, drop down to negative 7. On the right side, I can also distribute. 2x minus 6. Okay. Left side, I can still simplify down a bit. There's some like terms I can put together. Negative 12 and negative 7 makes negative 19. So I would have 4x minus 19 is less than, and then the right side is already simplified, so I just drop it down. Okay, so I simplified both sides. Now you can start moving things. I'm going to move my variables to the left. So I'm going to get rid of this 2x. So I subtract 2x, but I do it on both sides. 4x minus 2x is 2x. Drop down everything else. Now we're looking at the 19, saying how can I move it over or get rid of it? Since it's negative, you're going to add 19 to both sides. I'm left with a positive 2x and then negative 6 plus 19. That's like 19 minus 6, which is positive 13. Okay, my last move is to get x by itself. I'm dividing. Uh-oh, is that alarm going off? Shouldn't be. You're dividing by a positive. No need to switch the sign, my friends. We just have 13 divided by 2 over here. You can leave it as 13 halves. Okay, I'm perfectly happy with that. I think a lot of you like the decimal answer. So whenever you have a decimal, I'm fine with decimal answers as long as they actually end. Okay, if you were to have something crazy like that business, I would not want you to have that as your decimal answer. You would leave it as 7/13. But our answer right now, 13 halves, is just 6.5. That's a beautiful decimal. I'm happy with that. We can leave it like that. Okay, so x is less than 6.5. Let's graph it real quick. Make sure you remember how to graph. So 6.5 is going to go here. You could count by halves. That kind of makes sense. So this would be 7 and then 7.5. This would be 6 and 5.5. You could even put the point zeros if you wanted to be fancy. Okay, now open or close, left and right. Well, that was easy. It's the same symbol as this dude. Open circle, pointing to left. All right, so you are going to have 2 practice questions to do, and you are going to enter them into the entry task like we've always been doing. So they're in the entry task, just to warn you, for these 2 questions down here, you would enter in the answer, and then you would have a question that says, what would the graph look like? You would either choose open to the left, close to the left, open to the right, open, close to the right, okay? So that's how entry task is going to go. So here are your 2 practice questions. Here's 5 and 6. Okay, we got 2y plus 3 is less than or equal to 5 times a set of parentheses y plus 6. Okay, number 6, 4x minus 10 is less than negative 18. All right, those are your 2 practice. You're going to solve and graph. Maybe I should write that. Solve and graph. Okay, have those ready for your entry task. Bye.